Okay, this example is example 5. It's a word problem. In fact, it's the same function that we used in the last chapter for this base. Remember the one about did the baseball clear the fence? Same thing. It says a baseball is hit 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to level ground. The path of the baseball is given by that function. Okay, where f of x is the height of the ball and x is the distance from home plate. What is the maximum height reached by the ball? Again, what are they asking us for when they ask for the maximum? In terms of a parabola, it's the vertex, right? Remember that because this thing has a negative in front of it, quiet, because this has a negative in front of it, it opens down. So the vertex is actually the maximum point down the path of the ball, right? So how do we find the vertex? Could we put it into the standard form and then just read it off the equation? Sure. But remember the formula we did at the I had on the first slide? What's the formula for H? Negative B over 2A. It's much easier. Just find the H by plugging into that formula. Right? In this case, here's our A is this, and our B is 1, because it's just X, right? So plug it in, negative 1 over 2 times negative 0.0032. Okay. Is that the maximum height of the ball? Right, because remember that the X is telling us the distance from home plate. H is just one of the coordinates of X. So for one point on, it's the vertex. So this is an X value. That's a distance from home plate. How do we find the height of the ball at that distance? Plug this in the place there and there. Oops. So K will be negative 0.0032 times 156.25 squared plus 156.25 plus 3. So that is 81.125 feet. So the maximum height of the ball is 81.125. It occurs 156.25 feet from home plate. Right? So understand in this problem, they ask us for the f of x. They wanted to know what is that maximum.